webinar. I'm Rob Taylor, and I'm excited to introduce you all to IBA's latest patient QA software, myQA iON for radiation therapy. Please note that this session is recorded, and if you have any questions at all, please put them in the chat and I'll answer them at the end of the webinar. Before we get stuck into it, I thought I'd slip this in as it's something we are really excited about. In case you have not heard, Gamma Guru's MV dosimetry audits have been certified by NADA. This means we can provide your department with level 1B, 2 and 3 dosimetry audits. This work will be performed by ACP SEM certified medical physics specialists to ensure the highest level of accuracy for you to be confident in the outcome and your patient treatments. Please get in contact with me if you're interested in learning more about this program. Okay, back to the main point of today's webinar, combined efficiency in patient QA. To start off, I thought it'd be good to highlight some of the needs of a patient QA solution. First off, we need to ensure accurate and unbiased QA results, using a system that is unbiased and independent from the treatment planning system vendor. We need to utilize all DICOM information from your treatment planning system. We need to analyze your results using advanced 3D tools such as DVHs and clinical goals. We need to identify the source of any potential dose deviations or errors. And we need to understand the clinical relevance and source of potential deviation and errors. All of this leads to the safe delivery of your patient's treatment. With that, IBA have developed myQA iON, a unique patient QA software environment featuring an automated workflow and best-in-class algorithm to maximize your efficiency and accuracy. myQA iON offers the following tools for your patient QA: 3D gamma analysis, inpatient geometry and gamma histogram, 3D dose difference displaying inpatient geometry, independent MU and point dose check verification, beam geometry display, plane complexity scoring, dose volume histogram and DVH statistics, and clinical goals table with DVH criteria. With myQA iON RT, you can validate your most demanding treatment techniques while ensuring patient safety without compromise. myQA iON is powered by the accuracy of the Monte Carlo algorithm SIMOCA. SIMOCA establishes a new standard for accuracy in secondary dose check and independent plane QA. It provides TPS dose errors and discrepancies with minimal effort and provides instantaneous feedback regarding treatment plan quality and achievement of planning objectives. SIMOCA utilizes a best-in-class Monte Carlo dose calculation algorithm with an outstanding academic pedigree to ensure the quality of your QA. If you're interested in more of a deep dive of the accuracy of SIMOCA, please go and check out the paper on screen. This paper compares the accuracy of SIMOCA Monte Carlo versus Variance Accuros. The conclusion of this paper found an outstanding agreement between the Boltzmann equation solver and Monte Carlo. Aside from the residual differences, both algorithms arrived at identical dose distributions. On screen is a brief overview of the calculation speed for different types of patient treatments. Please note that lower values of Monte Carlo uncertainty and fine calculation grid will increase calculation times. Just for your reference, the times on screen were captured with a dual 8-core Intel Xeon server with hyperthreading for dose calculation with final statistical uncertainty of 1%. So how does this all fit in with myQA iON? The initial SIMOCA secondary dose check provides comprehensive QA for all aspects of the plan creation workflow, starting from density corrections, HU definitions through the beam model, and algorithm evaluation under real clinical conditions to the final MU and dose check with the scoring of the plane complexity. In the logs workflow, we provide QA for the actual mechanical delivery aspects, RT logs containing information about actual delivered positions of the MLCs, the jaws, the gantry, together with actual MU data. All the logs information is then processed and represented as daily QA dose distributions on the patient CT. By combining both tools, all LINAC and TPS specific errors can be distinguished, detected, and analyzed, which is a unique offering compared to the traditional phantom-based QA methods and can be performed for every treatment fraction. myQA iON has an optimized automated workflow to save time and speed up your QA process. You can speed up your QA processes with automated dose calculations that are performed in the background. You can assign tasks to specific users with the optimized patient or task view list, identify any potential errors or dose deviations using advanced yet easy to use tools. So now I'm going to play a quick video showing the workflow of myQA. myQA iON is a web-based patient QA system for pre-treatment and during treatment QA. The software can be accessed from any computer within your facility. When you open the web page, we can either see a task list or a patient list, depending on your preference. Using these to make your objectives simple and easy to complete and gives you a full overview of all tasks in real time. Here we can see which patients need approving, which QA plan has been rejected, and which patients may need more data. The following will demonstrate how to perform a plan verification. First, we need to import a plan. To perform a recalculation of the dose, to perform an independent dose check, all DICOM objects from the plan must be exported from the treatment planning system to myQA iON. As soon as the plan has been imported to the system, myQA iON automatically starts the Monte Carlo calculation. The doses are calculated in minutes, and the plan analysis is launched automatically without any need of user interaction. This ensures the system is working efficiently and so that you do not need to wait for results. We can now open a calculator plan. Here we can see the original dose from the treatment planning system, the dose myQA has calculated, the dose difference between the treatment planning system and myQA, and the 3D gamma index. As we review the plan, we can see the gamma index values for each structure as well as the PTV. myQA iON gives you all the info you need to quickly and easily approve or reject a treatment plan. The next step is to look at how we can review the plan delivery during the patient's treatment. To do this, we use the log files direct from the treatment machine. Here we have several log files for a patient that is receiving treatment. Again, we can see the planned dose, the delivered dose calculated from the log files, the dose difference, and the 3D gamma index. We can also see a log file history. This will highlight any recurring or random errors, enabling you to investigate whether your patient setup or machine performance is causing the deviations. As mentioned, myQA iON is installed on a dedicated server, fulfilling the minimum requirements. There is no need to manage any individual clients, as it is a web-based application and can be accessed from any workstation in the same network as the server. Data from your TPS and LINAC is fed into the application to provide a comprehensive patient QA solution. myQA iON is compatible with all variant Linux and all C-ARM Electa Linux. Support for more novel treatment machines such as MR Linux and CyberKnives will be coming soon. myQA iON is compatible with all your treatment techniques such as 3D conformal, IMRT, VMAT, and SRS. In summary, myQA iON provides you with a combined efficiency in patient QA. The powerful combination of Monte Carlo and log files allow the fast analysis of all sources of possible error for increased patient safety. Before we wrap up for today, we would like to quickly give you a sneak peek of what's next for the myQA ecosystem. We are pleased to introduce you to myQA Proactive, an upcoming risk management tool for radiation oncology. myQA Proactive will be the benchmark for proactive risk management, allowing you to stop using the TG100 spreadsheets and be confident on your risk evaluation. Thank you all for joining today's webinar. I hope you found it a useful introduction to myQA iON for radiation therapy. Please let me know if you have any questions at all. And as this is the first time we have showcased this software, any feedback you may have would be greatly appreciated. Thank you.